Hi students, welcome to chemistry class. In the previous class we had discussed about how to write the chemical formula. Now in this class we are going to learn about the concept of mole. So let's see what actually a mole, then why this concept has been introduced. You see that as you know that the size of the atom is very small and the mass also is very small. So then if you take a particular mass of an element, so in that mass of an element contains how many atoms are there. So it is very difficult to calculate number of, because we cannot count each and every element. Say for example, take a 15 gram. So 15 gram, in that how many atoms are there, then how can you tell that one? So it is not possible. So in order to solve this difficulty, so they have used the concept of mole. Say for example, just in order to understand this mole concept, let's give one particular example. Say in the case of bank, so they will be having different denominations of different coins are there. Say a 1 rupee coin having some particular weight and 5 rupee coin having particular weight, like that. So you might observe that they will when they get the coins, they will get separate as 1 rupee, 2 rupees, 5 rupees, like different denominations. Then they are not going to calculate count each and every coin. Instead of that, they will count the weight of the coins. Say for example, if they get 60 coins are there, so just they will take the weight of the coins, then they will come to know that how many coins are there in that particular. For example, if you take 5 rupees, 5 rupee coins, it is having weight of 6 gram. Okay, so then so 1 5 rupees coin measures about 6 gram. Then if they have 30 gram, say a person gives some coins to a cashier, then the mass is around 30 gram. Then if it is 30 gram means, then how many coins are there? Then you can calculate. There are 6 coins. Sorry, there are 5 coins in the particular bag. Like that, by measuring the mass of a coins, we can calculate how many numbers of coins are there in a particular bag. So the same concept, it is applied in the case of atoms also. So if we know the mass of an element, so which is related to, it is related to the number of atoms. It is related to number of atoms present in that. So this is actually what we call mole concept. So by knowing the mass of an atom, it is related to number of atoms present in that particular mass. This is actually what we call mole concept. Now let's define what is mole. A mole is a mole of any species, a mole of any species. It may be atoms, ions, or molecules. Atoms, ions, molecules is that quantity in number is that quantity in number is that quantity in number having a mass equal to having mass equal to its atomic or molecular mass. Its atomic mass or molecular mass in grams. means if mole is nothing but it is a particular value, means for example we say that 1 dozen means how much? It is 12, right? So the number is fixed. So like that, if you take a particular mass of an element, in that particular mass of element, how many number of atoms should be there, how many number of ions should be there, how many number of molecules should be there, so that we cannot calculate it, right? So here, in order to know the exact value, so exact number of atoms present in a particular mass, so we have used this concept of mole. So let's say that how many number of atoms are present in a one particular mole. So let's calculate this one. Say for example, the mass of carbon is 12 gram. Okay, so mass of carbon atom is 12 gram. Then an element. Okay, so here if you want to calculate number of carbon atoms, if you want to calculate number of carbon atoms in 12 gram, so what we have to do? So the mass of that one, then mass of carbon, and another one mass of one carbon atom. So mass of carbon here it is 12 gram, and mass of one carbon atom is 1.99 into 10 to the power of 24 into 10 to the power of minus 23. So if you solve this one, then you will get the result of 6.022 into 10 to the power of 23, means in 12 gram of carbon element, so we have this number 6.022 into 10 to the power of 23 number of carbon atoms are present. So by this way, means this is experimentally obtained value. So this value is constant for all the atoms, ions, and as well as molecules also. So let's take one more example. Instead of carbon, let's take oxygen. So oxygen molecule, now we have taken oxygen molecule. So mass of one oxygen atom is 16, O2 is there, means 16 2s are 32. So now we have to calculate for oxygen atom, say mass of oxygen, mass of oxygen molecule, and mass of one oxygen atom. So it is 32 divided by 5.313 into 10 to the power of 23. So the mass of this is oxygen and this is mass of one oxygen atom. Then if you solve, again we obtain the same value, 6.022 into 10 to the power of 23. So here in the previous case we have taken atoms, in this case we have taken molecule. So in both the cases, whether you take an atom or a molecule, so there will be a constant number of particle, and that is 6.022 into 10 to the power of 23. So this constant value is called as Avogadro number. This constant value is called as Avogadro number. It is represented as N0 or L. This is the constant value. Then, so in order to express this Avogadro number, so here the mass of an element, it should be expressed in terms of grams, either gram atomic mass or gram molecular mass. In that gram atomic mass, they contain this Avogadro number of particles. Say, let's see that. So, mass of an element, it should be expressed while calculating in the mole. We should always express in terms of gram atomic mass. Gram atomic mass, gram atomic means it is for atom. If it is molecule, we have to use gram molecular mass. Say for example, one oxygen atom. One oxygen atom means we'll write O. Okay, this is one oxygen atom. And mass of one oxygen atom is 16 unified mass. We know how to represent atomic mass unit, 16U. And while calculating in the moles, it should be expressed in terms of grams, that is 16 gram, that is gram atomic mass. So in this 16 gram of oxygen, how many number of oxygen atoms are there, that we have to calculate. So in that 16 gram, we have the constant value of 6.022 into 10 to the power of 23. So this value means the mass of an atom which is expressed in terms of either gram atomic mass or gram molecular mass. In that mass they contain Avogadro number of particles. This is actually what we call mole concept. So this is for atom. Then let's see that for mass, for molecular mass, say mass of an element, say gram molecular mass. It should be expressed in now gram molecular mass. Say for example, mass of oxygen molecule. Mass of oxygen molecule. Molecule means we write O2. Okay. So one oxygen atom is 16 and there are O2 is there, so it is 32 unified mass, and it is expressed in terms of 32 gram. In 32 gram, how many oxygen atoms are there? It is again 6.022 into 10 to the power of 23 oxygen atom. Means whether it is a gram atomic or gram molecular, in both the cases it contains same value. So this is actually what we call gram mole concept. So let's see that. So there are some numerical problems are there. So let's solve that one. Before that, first let's see how to express these if they are given in terms of gram atomic mass or gram molecular mass or in terms of number of particles. So how to express mole in terms of mole? Let's see that one. So expressing number of particles of a substance in terms of mole. So this is for elements. So for compounds, so here you can mention or not, it is not necessary. Just if they ask number of particles means either it may be atoms or molecules it will come. So in case while finding mass it is necessary substance So if it is given in terms of mass while finding the mole, so we should, so the given mass and gram atomic mass we had to compare, then we will get the mole. We can express it in terms of mole. So this is for elements, and for compounds So these are the different ways to express the mole in terms of particles, or it is in terms of mass. So let's solve some problems related to this. So let's see some problems. Calculate the number of moles of the following. Calculate the number of moles. The number of moles of the number of moles for the following. For the following. So first one, 52 gram of helium. And second one, 12.044 into 10 to the power of 23 number of helium atoms. Number of helium atoms. Now look at here. So we had to calculate moles, and here one, in the first problem they are given that they have expressed in terms of gram. Okay, so they are given mass of a particular atom, that is helium, and here they express in terms of atoms. So in both the cases we have to find what moles. So let's see first one. Let's solve first one. So number of moles, you can write directly moles of helium. So here they are given first in terms of gram. Say given mass by gram atomic mass, given by gram atomic mass. So given mass is 52 and gram atomic mass, it is not mentioned here, but we should know the mass of some elements, and the mass of some element, this helium is 4. So if you solve this, you will get 4 ones are 4 13s are. So there are 13 moles present in 52 gram. Now next one, second problem. It is given in terms of number of particles. Say again, so number of moles of one helium, and they are given in terms of particle. So what have to take? Given number of particle, given number of particle by Avogadro's number. So given particle number is, it is 12.044 into 10 to the power of 23, and Avogadro constant is, we know that 6.022 into 10 to the power of 23. 23 get cancelled, 6.01 and it is 2, so it is 2 mole. So in this way we can calculate if the given mass, use this formula, and if they give a number of atoms and apply this formula to find the number of moles. This is one kind of problem. Let's see another kind. Next one, calculate the mass of the following. Calculate the mass of the following. Say first one, 0.5 mole of nitrogen gas. So they are given nitrogen N2 is a molecule. So we have to concentrate on molecular mass. Second one, 0.5 mole of nitrogen atoms. Then third one,